Hello everyone, this is your Cisco trainer and welcome you to part 7 of lecture 6 from the course CCNA 200-301. In today's lecture I am going to talk about VLSM in details. What is VLSM, Variable Length Subnet Mask? Variable Length Subnet Mask usage in a real scenario, answer to subnet question according to giving topologies, some subnet questions and practice. It's 100% completely free course to pass the CCNA exam 200-301. And if you liked the video, leave a comment and share to help spread this free series of videos. And if you haven't yet subscribed to my channel, stay tuned please by just clicking on subscribe button, thumbs up, hit the bell icon, and do not miss out on my future videos. Now let's jump and start. What is VLSM? Actually, the meaning or the name of VLSM is divide a given IP address into multiple unequal size. So a variable length subnet mask or VLSM is the process of creating a subnet of different size. VLSM technique is used to make your use of network more efficient and usable within different network size. Divide an IP address space into a hierarchy of subnet of different size without wasting a large number of IP address. In this diagram, we have 4 LAN with one connection, each LAN with a different IP address with different subnet mask. So this is called VLSM. Variable length subnet mask is more efficient and convenient to the network. VLSM is more complicated than FLSM. Why it is more complicated than FLSM? The process of dividing IP address, FLSM and VLSM are the same, but with a little difference. We use FLSM with a fixed length subnet mask. Pretend you have 2 or 3 LAN, each LAN with the same IP address, same subnet mask. For example, if you have 3 LAN, LAN A, LAN B, LAN C, each LAN will require 30 hosts with the same subnet mask with the same CIDR. But VLSM is a little bit different. With a VLSM, each LAN has different IP address, different subnet mask. But it is easy if you use the proper method and steps. VLSM is well structured for an organization. The big disadvantage of VLSM is more complex and tricky. Need more practice and exercise. Within this diagram, we need 200 IP address, but we have to play, or we follow the rule of how to play with the finger games. To the power of 7 minus 2 is equal to 126. To the power of 6 minus 2 is equal to 62. To the power of 5 minus 2 is equal to 30. So this is called a finger games. Answer the subnet question according to given topology. Here we have 4 LAN with a one connection or point-to-point connection. Each LAN required its IP address. You have to remember if you want to become a master in a VLSM or subnetting. Start from the largest subnet of address space, then the second largest and the third largest. So here we have 4 different LAN. The first one, the largest, is UK Lan A, required 120 hosts. Or the second largest is Canada LAN B, is required 60 hosts, and the third one is Canada LAN A, required 25 hosts. So now let's jump and start it and do subnetting on UK LAN. It is our job, or it's your job as a network engineer, to determine network address, first usable address, last usable host, broadcast IP address, total number of host address. UK LAN A require 120 hosts from the below address space 192.168.0.0/25. You have to remember the cram table or cheat sheets. Cheat sheets prepared from 3 different parts: group size, subnet mask, or CIDR. So it is the rule to borrow from the host bit. In this scenario, with the UK LAN A require 120 hosts, we borrowed 1 bit. If we play the game to the power of 1 is equal to 2, it means we have 2 network with to the power of 7 minus 2 is equal to 126. Means each network will be fixed or fed with 126 hosts. So the network ID or the first network address is 192.168.0.0. the first usable address in the first network is 192.168.0.1. The last usable address is 192.168.0.126, less than 1 from the broadcast IP address. The broadcast address is 192.168.0.127. The second method is same, gave you our second method as well. If you prepare yourself with the first method or with the second method, both are the same. The second method either convert decimal number into binary and vice versa. So the first 192 is equal to 11000000, and 168 is equal to 10101000, and the rest of them. So it is the second model. Don't worry if you have problem with how to convert decimal number into binary. I have recorded a video. You can click up on a little eye on the right top corner of the screen. Or if you faced any problem with the conversion of decimal number into a binary, please feel free to ask a question, leave a comment down below. I will answer to you very soon. After doing VLSM or subnetting, network address will be all with the /25. Why /25? Because we have borrowed just one bit from the host side. The network address, the broadcast address, the total usable host address will look like this. The second largest IP address is Canada LAN B. So again, the process same as I told you. Now we should determine the list of address that we mentioned here. Example, Canada LAN B require 60 hosts from the below address space 192.168.0.0/25. Here we borrowed 2 bits, 128 and 64. Now we add these 2 borrowed bits together is equal to 192. So the CIDR will be /26, the first usable address, and the last usable address, the broadcast address. As I told you, we should play with the finger game. 2 to the power of 2 is equal to 4, to the power of 6 is minus 2 is equal to 64. It means now we have 4 networks. Each network will have 64 IP address. So the first network and the last network, the usable address and the broadcast address will look like this. Network address, broadcast address, last usable address, and total usable host is equal to 62. All address will be /26. Now let's jump to the third largest. Canada LAN A required 25 hosts from the below IP address 192.168.0.0/24. Here we borrowed a 3 bit. 128 plus 64 plus 32 is equal to 24. So 2 to the power of 3 is equal to 8. It means we have 8 network. 2 to the power of 5 minus 2 is equal to 30. Each 5 network will have a 30 usable host. So the first network ID will be 192.168.0.192. The first usable address is 192.168.0.193. The last usable host is 192.168.0.222. And the broadcast IP address is 192.168.0.223. Network ID and the broadcast ID I colored red because we are not able to use neither network ID or nor broadcast ID. Now the IP address for the Canada LAN A will look like all with the /27 with the usable total IP addresses 30. Let's jump UK LAN B, which required 10 hosts. Again, we should determine network IP address, first usable host, last usable host, broadcast address, total number of usable host address. So the processes, as I told you, is the same. LAN B required 10 hosts from the below IP address space 192.168.0.0/25. And here we borrowed 4 bits. 128 plus 64 plus 32 plus 16 is equal to 240. 2 to the power of 4 is equal to 16. 2 to the power of 4 is minus 2 is equal to 14. It means we have 60 network. Each network will have a 40 usable IP address. The network ID is 192.168.0.224. First usable address is .225. The last usable address is 238, and the broadcast address is 239. This is how we subnet, and we start from the largest, second largest, third largest, and fourth. It means from largest toward to smallest with it VLSM. The address of UK LAN B will look like this, each with /28. Network address will be like 192.168.0.224/28, and the rest of them: first usable address, last usable address, broadcast IP address, total number of usable host address will be 14. Now let's do subnetting on point-to-point connection between site A and site B. Point-to-point connection requires two hosts from the below address space. The address space is the same, 192.168.0.24, and the process are also the same. With the point-to-point, because we need two public IP address, 128 plus 64 plus 32 plus 16 plus 8 plus 4 is equal to 252. It means to the power of 6 is equal to 64 networks. To the power of 6 minus 2 is equal to 2. It means we have two public IP address. A 64 network each will have two public IP address. Network ID is 192.168.0.240. First usable address is 192.168.0.241. Last usable address is 192.168.0.242, and the broadcast IP address is 192.168.0.243. This is how we done our subnetting on all LAN A, LAN B, LAN C, and point-to-point between LAN A and LAN C, or between two sites. The address will look like this, all address with a /30, and the total usable host is 2. The lecture we have covered. What is VLSM? VLSM means or the process of dividing one single IP address into multiple unequal parts is called VLSM or subnetting. The process of subnetting, FLSM and VLSM both are the same. Variable Length Subnet Mask usage, where we should use VLSM. VLSM usage is really convenient, efficient on a real network. It will make easy the administration of network for network engineers. Answer to submit questions according to the given topology that we already have done it. Thank you for watching. That is all for this video. If you want to show your support, please subscribe the channel, like the video, leave a comment, and share the video with anyone else studying for CCNA.